Today we are joined by Chris Wright, Vice President and CTO of Red Hat, and specializing in emerging technologies and a visionary for our engineering team. So, Chris, welcome.
Thank you.
So, Chris, tell us. I have a couple of questions to ask you, and several of the questions are about what is Red Hat doing in regards to Internet of Things and artificial intelligence and serverless technologies.
Sure. So those are kind of the buzzwords du jour. And each of those we're approaching those in different ways. So we think, for example, we think of IoT as, call it a market, an emerging market that is something that we're addressing with the technologies that we have today. So we think about maybe a multi-tiered architecture with devices, all the things out there, generating data. And those devices are generating data, and they need to send that data somewhere. So the first hop in the network, at the edge, you're sending data to a gateway of sorts that's collecting, aggregating, and then routing that data to and potentially making some decisions based on that data. And that's a space where we have middleware technology that fits the purpose well. So adapters for IoT-specific messaging protocols and some capabilities around business processing and rules to do analytics and really understand the data that's being generated from these things, these devices. And then ultimately you can also picture a central tier all the way back in a cloud, whether it's private cloud or public cloud. And where you could do deeper analytics, some data aggregation. And so our view is we're not so much in the device side, like whether that device is a phone or a small sensor. It's not necessarily a place where Red Hat spends a lot of time, but as you get inward from the device, there's data aggregation, data routing, and analytics associated with it. So we see IoT as a big space. It's dependent on the industry. So there's smart buildings, there's companies that there's initiatives around lighting systems that need to be turned off when there's not somebody in the room or that kind of thing. And then there's agricultural applications, there's industrial applications, and if we talk to our telecommunications customers, it's a big area of investment for them. They see a huge opportunity in creating the infrastructure to support all the things that are going to connect to their network and hopefully generate revenue for them.
And in the government sector, there's a lot of funding for a lot of these smart projects.
Oh, sure, right.
So
smart cities.
Should be uniquely positioned to help with these Internet of Things projects going on. But what about AI and serverless?
Well, AI is a different kind of investment for us. So here we're looking at, number one, how can our platform be just an awesome platform for running AI workloads? And that starts all the way at the bottom of the stack in Linux, doing hardware enablement for things like GPUs and FPGAs so that we can create an accelerated environment for machine learning workloads. And then as you go up the stack, we need to make those hardware and accelerated hardware environments, GPUs, FPGAs, available to virtual machines and containers where applications are running. So that's OpenStack and OpenShift. And then ultimately, we want to be able to help developers build applications that take advantage of machine learning frameworks and workloads to provide intelligence into the application. So that could be making a recommendation to a user, like you see on your phone. You open up your favorite app, and you're getting, whether it's your data feed or whether you're doing purchasing, you're getting some recommendations. Those are often done with machine learning in the background, or how you interact with an application using natural language, whether you're actually speaking or more free-form text writing. Natural language processing is an example of how you can integrate machine learning directly into an application. So we're looking at it from make our platform be an awesome place to run machine learning workloads, and then how do you integrate with traditional applications so that the data science side of the house and the developer side of the house can kind of come together and build intelligent applications.
There's this fear of artificial intelligence. Should we fear it?
Well, it's a great, healthy skepticism because we don't completely understand what happens inside the kind of decision-making process of a machine learning algorithm. So I think there's some important society questions around what are the requirements for the data that was used to train a model. Does that data need to be public? Do you need to be able to get access to that data so that you can understand how a trained model was created? And especially in the context of something like an autonomous vehicle that's making life and death decisions, we need to be sure that we can make that black box, that decision-making black box, something that's visible, transparent and visible inside. At the same time, the sophistication, the kind of the Skynet, the robots that are going to take over the world, that's a little, I call it hyperbolic. It's a little extreme. Okay. The technology is really not there. If you take, for example, something like AlphaZero, which recently could beat expert players at Go, take that same model and point it at a different problem like checkers, and it can't do it. So there's a lot of work that needs to be done in the kind of academic side of machine learning to get to that point where we're really replacing humans from a creative and a true intelligence point of view. And we need to pay attention from here all the way into the future, that we're not creating technology that is something we don't understand and something that is a problem for us. But I don't think it's more the decision-making process and
yes.
the data associated with it. You hear things like in an HR group, how you sift through resumes. So you feed a lot of text from resumes into an algorithm that tries to pick the best employee for your position. What implicit biases are part of that data? Right. Are you actually assuming that you create a level playing field and can find minorities and women just as eligible for the job, and it turns out that the implicit bias that's already existing in the data sets doesn't support that? So there is a lot of real reasonable things to be concerned about. I'm just not as worried about Skynet taking over the world.
Well, as an ex-list developer and all the bracket writing, I'm excited to see AI come back and where it's going to take us. And finally, Chris, if I had to, if we sat here next year, what do you think we'll be talking about next year? What do you think will be all the buzz? This year it was public cloud and software as a service and containers. What do you think next year will be like?
Well, I think of it as sort of an evolution. So a lot of the same topics will still be really interesting next year. They'll be more advanced, more evolved, maybe some new projects coming up to support things. You mentioned serverless earlier. Serverless for us is something that we are building in the context of Kubernetes, of OpenShift. And we are invested in a project called OpenWhisk. So we want OpenWhisk to run well on top of Kubernetes. A year from now, we'll probably be talking about how Kubernetes has continued to integrate something like a serverless environment to be more and more native to the platform. I think a lot of the technologies that we hear about today aren't going to be eclipsed by some big new buzzword. A year from now, it's going to be more about how sophisticated are we with deploying those and using those, because those kind of buzzwords, they get a lot of focus in the industry, but it takes time for people to understand how to use them. So we've seen Lambda has existed for a few years, and it certainly gets a lot of focal point. It's a focal point in the industry, but are all developers building applications in serverless environments? Not even close. So a year from now, we'll still be talking about serverless. We'll be continuing to talk about containers. I think we'll start to look at what converged infrastructure looks like and how containers and virtualization can really coexist as peers in your infrastructure. And we have a lot of work to really make the hybrid cloud and multi-cloud workloads really easily distributable with storage and networking. So I think we'll see less of hybrid as I could deploy here or there, and more of a hybrid where I can deploy here and there, and really building that kind of ubiquitous connected fabric and storage and backup and all the
I like that. Ubiquitous fabric. I like that. Well, Chris, can't wait to see what's going to happen in the next 10 years. Thank you for your time. Thank you for your leadership.
Absolutely. Thank you.